Yeah. In a previous class, about planning, right? Today, talk about application. Allegation, if you're not comfortable with, it does not matter at all. But you are going to, can this be solved without using that method because it is processed by average. For using the weighted average, you will be able to solve the question. Is because it saves time and it can it a lot of areas, right? To very quickly back to what we did in the previous slide. What is method to find weighted average? Typically, you will see allegation being, but it can be not just limited to constant, right? For example, the question I had was this one. There are two sections in the class A. The number of students in the first is 60. The average score of these students is 70 marks. We have to find the number of students in the other section. Average, the class average becomes 54. Right? So what I said was, suppose if I take this as X, I can say the total first section, section A, total marks will be 60 into 70. And total marks for the second number into average. This becomes the total marks of the entire class. Right? The number of students, which is nothing but 60 plus X. Marks upon average. So this comes out to the average 50. Formula for weighted average. If I solve this, I should be able to get the answer. Right? Just a second. Yeah. As I said, you can solve the question without allegation as well. This will give you a perfect answer and there is no problem per se. What was allegation? I had said that average meant everything becoming equal, and therefore here all of these students in the first section have surplus marks from with respect to the average. What is the total surplus they have? They have a surplus of 70 minus 54 with each student. There are 60 students. This surplus would be then distributed to the students who have a deficit so that everybody's marks becomes equal, and the deficit with the students in the second section will be 54 minus 30. The number of students is X here, so this becomes a total deficit. The total surplus has to be equal to the total deficit. I equate this to solve for X, and therefore what I get is something like this. The pictorial form for this equation is called alligation. So what you do is you write the total marks or the average marks for each section at the top. So 70 and 30. You write the overall average in the center, 54. And you take the differences. 70 minus 54 is a 16. 54 minus 30 is a 24. The numbers at the bottom will be the ratio of the weights attached to that score. In this case, the ratio of the number of students. 24 and 16 is in the ratio, if I divide this by 8, 3 is to 2. And therefore, the number of students has to be in the ratio 3 is to 2. Because the first section has 60 students, corresponding to 70 marks. The number of students here should be, since the required ratio is 3 is to 2, therefore 60 is to 40 and 40 becomes the answer. This is what we did when we talked of alligation, right? How do I then use it for uh, concentrations, where you would typically see alligation being named actually, right? For example, this question says, how much water must be added to 60 liters of 80% milk solution? So the solution has 80% milk and 20% water. The total volume is 60 liters. I want to make the solution 50% milk solution. So I will dilute it adding water, right? So what is the volume of water? Again, the question can be solved directly as well. Because the amount of milk has to remain constant. So I say, if X liter of water is added, then the amount of milk in the first part, this has 60 liters of 80% milk solution. I'm adding X liters of water. So 80% of 60, the amount of milk in the first container that I have, plus the amount of milk that I'm adding. Since I'm adding water, water has 0% milk. So plus 0% of X. Of course, there's no need to write this. Upon the total volume, that is 60 plus X, should now become 50%. As you can see, this is the exact expression for weighted average, and therefore I could alligate as well. When you're alligating two solutions, what you do is you take the percentage or the concentration of one solute and alligate those concentrations with the overall concentration of the solution. That is the mixture. What you get at the bottom is the ratio of the volumes of the initial solutions. For example, in this case, first solution has 80% milk, so I write 80. To this, I am adding water, which has X, which has 0% milk, so I write 0. Finally, I want a 50% milk solution, so I write 50. And I alligate. The difference here is 30. The difference here is 50. So the volume of the two, that is milk or the solution with 80% milk and water, has to be in the ratio 5:3. Since this we know is 60 liters, wait, sorry. Since this is 60 liters, I can say that for 5:3 ratio, because 5 12s are 60, so 3 12s are 36 becomes the answer. Right? Alligating mixtures. And again, we've done a question related to this, which did not talk of mixtures per se, but an average price. This was the question that we did, said two types of rice are being mixed. The prices are 72 and 57 rupees per kg. The mixture costs 63 per kg. So there is an average price involved here. What is the ratio in which the rice will be mixed? Again, a very similar question I say. If the rice are mixed in the ratio X and Y, the total price will be 72X. The price of the other one will be 57Y. The total weight will be X plus Y. Total price upon total weight should give me the average price. Again, the expression is the same that we have been writing for weighted average. And therefore, alligation can be used here. Because I'm trying to find out the average price, I will alligate the prices. The prices are 72 and 57, with the average being 63 for the entire mixture. I take the difference. So the weight of the two types of rice, the one at 72 and the one at 57, has to be 6:9 or 2:3 kgs. If you solve this equation, you will still get X:Y:3. Right? So this is something that we have done previously. Now we look at where alligation can be applied. And by the time we finish, we would be alligating a question in time speed distance. Probably you've been solving using equations alone. Yeah. So something happened. For example, look at this question. This is a profit percent based question. Says 1/3 of goods worth 1200 are sold at 10% profit. At what profit should the remaining be sold to get profit of 20% overall? because there are two quantities and there is a percentage profit on each of them. There is an overall profit on the entire thing. So if I alligate the percentage profits, I should get the overall profit percentage, right? Because again, this is a question that you would have definitely done if you've completed profit loss and discount. A question that was asked in the previous CAT as well, with a little different numbers, but yes, the concept has been asked. What you would have probably done is you would have said, okay, 1200 rupees. 1/3 of it is 400. Remaining is 800. This is sold at 10% profit. So it is sold for 440. I need a 20% profit overall. 20% on 1200 is 240. And therefore, overall, it has to be sold for 1440 rupees. Out of this 1440, I've already earned 440 rupees. And therefore, I need an extra 1000 rupees. This becomes the cost price. This is the selling price. I can find the profit percentage. Outright profit loss and discount. But if I try to write the equation for this, what I'll say is 10% of 400 profit on the first one plus P% of 800 profit on the second part upon 400 plus 800 should be equal to the overall profit percent, which is 20%. As you can see, again, I get an expression which is the same expression that I've been using for weighted average. My question is, what are the weights in this case? For example, for the number of students, the weights were the number of students 60 and 40. What are the weights associated, or when I alligate, what will be the numbers at the bottom? The numbers at the bottom would be the numbers that are written in the denominator here. So when you're allocating profit percentages, you get the ratio of the cost prices, right? So I say that there is 10% profit on the first part, X% profit on the second part, right? Overall profit required is 20%. And what is the ratio of the cost price? For 10%, the cost price was 400. For X%, the cost price was 800. Right? Using alligation, I can solve. And as I said, all this will do is help me save some time. So the ratio required of differences has to be 1:2. I can take the difference here. The difference comes out to 10. The ratio of differences has to be 1:2. If this part is 10, what should be this part? 2 5s are 10. So I multiply 5 to this, I get a 5. Right? Since the average profit is 20%, on one part the profit was less than 10, on the other part it has to be more than 10. So add 5 to 20 to get answer as 25%, which you would have in any case gotten from here as well. Right? So if you're finding out profit percentages, you can alligate. Alligate percentages for profit. If it is a loss, just take a negative value. That's about it. And at the bottom of the allegation, the numbers that you get or the ratios that you get are the ratios of the cost prices involved. Without any exception, this can be done. What if I change the question to this? Again, simple interest question that you must have definitely done if you've done SICI. Says part of rupees 10,000 is lent at 8% and the remaining at 12%. Simple interest earned is 3,800 rupees in 4 years. What part was lent at 8%? Of course, this does not require me to alligate. Since it's a simple interest question, there is a very good chance I'll solve it using the formula for simple interest itself. Right? So if I say that X rupees is invested at 8%, that would mean at 12% I will put the remaining money, that is 10,000 minus X. Just write the formula for simple interest. On the first part, simple interest will be principal into rate into time upon 100. On the second part, the simple interest will be principal into rate into time. The dots are the multiplication signs. And the total simple interest is given as 3,800. Solve. Right? The problem is takes a little bit time to solve. And therefore, some of us might feel, okay, it's a conceptual question. I can very well go about solving it conceptually, right? For example, there are two parts, x at 8% for 4 years and 10,000 minus x at 12% for 4 years. Not of, but for. Now this 12% is nothing but 8% plus 4%. Right? So I can rewrite this saying that on 10,000 rupees, I am getting 8% for 4 years. And on some amount, that is this one, I am getting an extra 4%. Suppose this amount I'm taking is A. Now, what will be the interest on 10,000, 8% for 4 years? 8 fours are is 32. So on 10,000, it will be 3,200 rupees. But the total interest earned is 3,800. There is 600 rupees extra that has to come from here. Right? Now, if in 4 years I get 600 is simple interest, in 1 year the simple interest would have been 150 rupees. So I can find the principal on which 4% gives me 150 rupees in interest for a year. So I say 4% of A is equal to 150. Solve for A. Right? Simple interest, additive, linear, break down into parts, add the parts that are easier to solve, solve for the remaining part. But what I'm saying is I can still alligate. Right? And how do I alligate? If I talk about the overall percentage return that I get, or the overall interest percent that I get, I will write the equation as, see, 8% for 4 years means a net rate of 32%. And 12% for 4 years means a net rate of 48%. Right? And therefore, I can say 32% of X plus 48% of Y upon X plus Y. The total interest upon the total principal should give me the overall rate. What is the overall rate? The overall rate is 3,800 rupees on 10,000 rupees. 3,800 upon 10 upon 10,000 is nothing but 38%. So equate it to 38%. Right? From that equation, you get the ratio of x is to y. But if you look at it again, this is the representation for weighted average. And therefore, what I can do is I can alligate the percentage rates overall for simple interest in the two principles with the overall rate that I'm getting on the entire amount. So what I'm saying is 8% for one of the solutions for this could also be 8% for 4 years simple interest means 32%. 12% for 4 years simple interest means 48%. And the overall rate I'm getting is 3,800 on 10,000 rupees, which is 38%. At the bottom, I should get the ratio of the principals involved. So take the difference. 5:3. So if you split the 10,000 in 5:3, you will get the principals at the 2% rates, 8% and 12%. 5:3, 10,000 means 5 by 8 and 3 by 8. This will be 6,250. This will be 3,750. Saves on calculation, that is about it. Right? So if I know this, I might be able to have some extra time in the paper. One of the most precious commodities that is required during a CAT or an aptitude exam in general. Let's take it forward then. Time, speed, distance. A bus travels at 54 kilometers per hour. It covers 45 kilometers in an hour. With stoppages, find the time it was stationary in an hour. Any answers? As you can probably see, this question does not require alligation. right? Because the bus is traveling at 54 kilometers per hour and it has to cover a distance of 45 kilometers. So I can find out the time required. The time is nothing but distance upon speed. Distance to be covered is 45 kilometers. The speed is 54. This will give me the time in hours. Multiply this by 60. Should give me the time in minutes. So 54 and 69, 10, 6, 9 and 10, 5, 50 minutes. Okay. Therefore, the bus is traveling for 50 minutes. And in an hour, it would be stopping for 60 minus 50, 10 minutes becomes the answer. No need to alligate. But we know that the average speed is nothing but the total distance upon total time. So if you look at the equation here, you will see that if the time taken here is x, when the bus is stopped, the speed will be 0. So I can say the total distance will be speed into time plus speed into time. Speed when it travels, speed when it stops, upon the total time. I know it is 1 hour, but because I'm trying to find out the ratio of that 60, I'll just write it as x and y. This should be the average speed, which is given as 45. Because net the bus ends up traveling 45 kilometers in an hour. So an average speed of 45 kilometers per hour. The expression that we've been getting over and over again. Alligate the speeds, you will get the ratio of the times involved. So I say 54 when it travels, 0 when it stops, overall speed of 45, alligate. So the ratio of times involved should be 45:9 or 5:1. If you split 60 minutes into 5:1, you will get the time as 50 and 10. So the bus stops for 10 minutes, travels for 50. So whenever you have two things that you are mixing to get a central sort of a value, you can alligate. You just have to understand what values to alligate and what are the ratios of the weights that you will get. If you're talking about profit, you alligate the profit percentages or loss percentages, you get the ratio of the cost prices involved. If you're allocating the rate at simple interest, you get the ratio of the principals involved. If you're allocating speeds, you get the ratio of the times involved, right? Of course, if you're allocating mixtures, you get the ratio of the volumes. If you're allocating prices, you get the ratio of the weight of the two quantities, right? So as you can see, alligation can be applied to different areas. And now I take it a little bit forward and I say, what about this question? If you've done TSD, straightforward question to solve. A man covers a certain distance on a bicycle. Had he moved 3 kilometers per hour faster, I do not know the speed, he would have taken 40 minutes less. I do not know the time. If he had moved 2 kilometers per hour slower, he would have taken 40 minutes more. Find the distance. So when I talk of distance, speed, and time, I have to find the distance. So hopefully that will not be known. I do not know the speed. I do not know the time as well. The 3 variables that I do not know. And therefore, if I have to solve values for DST, ideally I would want 3 equations. And that is the first thing that should ideally come to mind. Make equations and solve, right? And what will be the 3 equations? Distance is equal to speed into time. The distance remains the same, speed increases. Distance is equal to speed plus 3 into t minus 40. And when the speed decreases, s minus 2 t plus 40. 3 equations, 3 variables. I go ahead and solve. The problem is I'll get the wrong answer. Why? Whenever you are solving an equation for DST, try that the unit for time is the unit corresponding to the speed. Because here we're talking about distance and speed in kmph. Ideally, the unit for time has to be hours, right? Unless you're equating distances for 2 types, st is equal to st, where the unit will get cancelled. It is a better idea to always make sure that the unit for time is corresponding to the unit of the speed. So ideally, I should solve for this. I would not add the minutes, but I'd add the hours because time is in hours, right? The second problem is, for people like me, do not have a good handwriting. We can tend to get confused in our 5s and our S's and our 2s, right? And therefore, this might take a bit of time. So what do? I go to average speed. And the moment I reach average speed, I will take it to alligation. All right. Yeah. So again, as I said, average speed is total distance upon total time. We know that. Conceptually, it is the speed at which you travel consistently to cover a distance in a given amount of time. So for example, I'm going from city A to city B. So first I'll cross city A, where there is a lot of traffic, and therefore my average speed, say, would be 40. Then I'll hit a expressway or a highway, where I'll drive at a speed of 100 kilometers per hour, assuming that is the speed limit. I'll reach the city B, where I'll again have to travel a part in city B, where my average speed will again drop. I'll drive slower, right? So the speeds are different, 40, 100, and 30 for different periods, time periods, distance periods. Average speed is that speed at which speed, if I drive consistently, I will still cover the same distance in the time like the previous case. That is the average speed, and therefore it is total distance upon total time, because the distance and time have to be same distance in the same time. Broadly speaking, there are two cases that you look at when you're talking of average speed. Again, these are very broad generalizations. Of course, there will be variations based on these concepts. So the first is when you're covering given distances at different speeds. For example, something like this. 3 paths in the form of equilateral triangle. Man starts from a point, moves with the speed of 10, 20, and 40 on 3 sides respectively, and returns to the starting point. Find his average speed for the journey. Distances are mentioned. Equilateral triangles, the same distances. The different speeds are given. Find out the average speed. So what I'll do is, I can assume a distance. So in this case, I assume that one of the lengths of the triangle is 40 kilometers, and therefore I'll find the time. In the first case, 40 kilometers will take 4 hours. In the second case, 40 kilometers will take 2. In the third, they will take 1. Total distance is 40 kilometers 3 times over, therefore 120 kilometers. Total distance upon total time, 4 plus 2 plus 1. Average speed. So in general, what I'm saying is, if there are 2 distances traveled at different speeds, for example, I go from home to office at X, come back at Y speed, find the average speed. If the distance is D, then the total distance will be twice of D, going and coming back. The times will be D upon X and D upon Y. Distance upon speed while going, distance upon speed while coming back. If you solve for this, you'll get the average speed as 2xy upon x plus y. So when 2 distances are mentioned, the average speed essentially is the harmonic mean of the 2 values, right? The second case that we already discussed is when we have different speeds for different times. For example, the bus traveling for some time at 54 and some time it is stopped, I get the average speed. As I said in the earlier question as well, so if a man travels for x kilometers per hour for t1 hours and at a speed of 5 for t2 hours, find his average speed. Total distance upon total time. In the first case, the total distance will be speed into time, x into t1. In the second case, total distance will be speed into time, y into t2. So the overall expression for the distance becomes xt1 plus yt2. Total time is t1 plus t2. You divide. This is the expression that I've been repeatedly talking about when I'm talking of alligation, weighted average. So if you have the times, if you have the speeds, you can alligate to find out the average speed. And therefore alligation, as we did in the question a little while back, right? Coming back to where we started from. What do we do with this? I'm sorry. The problem here is I do not have the speed, I do not have the time. And therefore, I look at a representative sort of a scenario. For example, my home and office. Suppose normally I travel with a speed of s, home and office. Speed of s will take a time of t, one way, right? What if I look at this situation now, where I go towards the office at s plus 3, come back at s minus 2. What will be the total time taken? In the first case, I will say 40 minutes. While coming back, I'll be 40 minutes late. So the net time will still be 2t. So when I was traveling with the speed of s, I would have taken a total time of 2t. T to go from home to office, t to come back. When the speeds change, I am taking t plus 40. Sorry, t minus 40 and t plus 40. Again, the net time will still be 2t. So if I compare these two cases, that is traveling with the constant speed of s, going and coming back, versus going at a speed of s plus 3, coming back at a speed of s minus 2, we see that the time and the distance is same. The distance traveled is twice of d, the time is twice of t, and therefore this speed s would be the harmonic mean of s plus 3 and s minus 2, because again distance is same, time is same, or the total time is same, right? And therefore I can find out the value of s directly. But because we're talking of alligation, what I'm saying is you have the speeds, you have the average speed, you have the times. You just put them in the equation, in the expression or the diagram for alligation should look something like this. There's two speeds are s plus 3 and s minus 2. The overall speed, average speed is s for the entire journey for the same time. And the time in this case is t minus 40. The time in this case is t plus 40. Now what happens is if you take the difference here, you will get the difference as 3. If you take the difference here, you'll get the difference as 2. This 2:3 has to be the ratio of time of the two times. And therefore, without any exception, you can write this kind of a expression. You can say t minus 40 upon t plus 40 is equal to 2 by 3. This becomes a lot easier to solve, right? Also here, I would have put the value for harmonic mean, and therefore I can say that the overall speed s will be nothing but s plus 3 into s minus 2 upon s plus 3 plus s minus 2. 2xy upon 2xy upon x plus y. If I go ahead and solve this, I'll get the denominator becomes 2s plus 1. So 2s square plus s is equal to 2s square plus 2s minus 12. The 2s square gets cancelled and therefore s becomes 12. So just by writing this equation, I get the speed. And writing this, I can find the time as if 3t minus 120 is equal to 2t plus 80. And therefore t comes out to 200 minutes. So instead of writing 3 equations and solving, by these two expressions, writing these two expressions directly, you get the speed and time and therefore the distance. Again, no need to do this. If you are, you might save some time. Right? Conclusive. I'm sure you would have realized I'm trying to be smart here. What if the times are not same? What happened here earlier was because I was saving 40 minutes on one way and gaining 40 minutes on the other, the plus 40 and minus 40 cancelled out to give me the same time. And therefore I picked up that question. But you are smart. You would have seen this. What if this happens? A man covers a certain distance on bicycle. Had he moved 3 kilometers per hour faster, he would have taken 40 minutes less. If he had moved 2 kilometers per hour slower, he would have taken 80 minutes more. Find the usual speed. G. Again, I'll try to reduce it to a case where the extra times cancel out, right? I have a plus 40, I have a plus 40 and a minus 80. Or vice versa, depending on how you write the plus or minus. So what I want to do is, I would want to double the 40 and keep the 80 as it is so they cancel out. So I take the LCM of 40 and 80, which comes out to 80. So what I'm saying is, let me break this down into 3 parts, 3 distances. The first distance I cover at 3 faster, s plus 3. The time taken would be t minus 40. The second I cover it again s plus 3. The time taken would be t minus 40. The third I cover it s minus 2. The time taken will be t plus 80. Instead, if I was covering the entire distance at a speed of s, a constant speed, average speed, what would be the time taken? If the time taken was t, for example, for each part, you will see that if each of these distances d, and typically I do the distance at a speed of s and a time of t, you will see that again for this entire distance, the time taken will be -40 plus 80 cancel out. So for the three distances, the total time will still be 3t. So the same distance, same time, and therefore s plus 3, s minus 2 have to average out to an average speed of s. Right? So irrespective of the differences that are given, you can reduce it to a situation where you have an average speed and some different speeds. How do I solve this then? I would alligate, right? What I know is at this speed, s plus 3, this is the total time required. At this speed, this is the total time that I'm traveling. If I alligate these, I should get the overall average speed, which I'm taking as s. So I write an expression which would look something like, yeah, so this is what I've written. This is how it will look like. The two speeds are s plus 3 and s minus 2. The times spent on those speeds are twice of t minus 40 and t plus 80. Because I've taken three different distances. The first two distances I've done at s plus 3, taking time t minus 40 and t minus 40. The last one I did s minus 2, taking time t plus 80. Alligate. The difference of 2, difference of 3. And therefore, you can write the expression, therefore, 2t minus 80 upon t plus 80. This upon this has to be equal to 2 by 3. And therefore, I can go ahead and solve the value for t. 60 minus 240 is equal to 2t plus 160, which means 4t is equal to 400. No need to write the three equations solving, you get the time per se, right? How do I get the speed then? Once I have the speed, I'll be able to find the distance. See, we know that time is equal to speed into distance. So if I look at this time, right? How do I get this time? It is for that distance at the given speed. So this will be nothing but 2d upon speed of s plus 3. This will be nothing but d upon speed of s minus 2. Right? The d's get cancelled out. And therefore, what I'm left with is 2 into s minus 2 upon s plus 3 will be 2 by 3. Solve for s. Right? In a way, time and speed are inversely proportional. So the ratio of time and the ratio of speed will be inverse. So using the same alligation, I can find the time and I can find the speed as well. And therefore, I will be able to solve for speed and time. Right? So basically just two equations and you'll be able to solve irrespective of the kind of numbers that are given. Right? That is how alligation can be used in a lot of cases. The point of all of this is, you don't have to know alligation. But the point is, in arithmetic, you will see that a lot of topics are interrelated. Right? Ratios find alligation in proportionality, time and work, linear races, concepts of say basic numbers would find application in percentages and so on. And therefore, it is important that while you're practicing, you look at these interconnections while you're practicing at home. So once you've done a set of questions, it is always a good idea to, when you come back, try to do them faster. Right? Once you know alligation, you can come back to question percentages and you might see that, okay, this can be done faster. And that is what will help you in the exam. And therefore, keep revising. And for that revising, revisit what you have done and rethink what you did. My basic thumb rule is don't use the pen while you're solving a question that you've solved. You will end up trying to think of a faster way to solve the question. Right? Again, thank you very much for your time. Hope this has helped. And we'll build on this in the next session. Bye.